I started on this Pac-Man Fit game almost a decade ago. That was our first launch on the Lens Studio. It took us 5 weeks. That's it. 5 weeks to go from prototype, developing assets, setting the stage, setting spatial elements, adding the computer vision elements for the game mechanics, everything. And launching the Lens was literally a minute and a half debacle.
Welcome to a new episode of XR and AI Spotlight, the show that gives the stage to the founders and makers pushing the boundaries of XR and AI. My name is Gabriele Romagnoli, I'm your host, and I'm here today with Ernest Spicer. Ernest is a data scientist, game developer, and technology executive developing new immersive learning and gaming experiences in AR powered by AI. And I don't say that lightly because Ernest and his team were the first to deploy AI on spectacles.
It was a challenge and it took us about 2 months. We had to go through and adapt the JavaScript code to be able to run our own APIs. Of course, we're in experimental mode, so we have to work with Snap. So that's what we've done is we pared down the specs to be able to call just about any AI API, whether it's OpenAI, which they already do, or Hugging Face for our own, Claude, whatever we want.
In this conversation, we will dive into his experience when developing for various smart glasses.
I've been in game development for over 20 years, and in game development, one of the biggest priorities is the IDE, the interactive development environment. Meta is terrible to work with, so you definitely don't want to try to develop on Orion. We've actually done some development on the Meta Ray-Bans, and that was a little bit of a nightmare. And with spectacles, they are the first platform in augmented reality to have an intuitive IDE mimics Unity. And to make it even easier, instead of doing like C++ and C# coding like Unity uses for a lot of its mechanics, it's been simplified to JavaScript.
How, as a Special Olympic coach, he sees AR helping the neurodivergent athletes.
I've been a coach in Special Olympics for on and off for about 13 years. And one of the issues with people that are neurodivergent is, doing the same repeating exercise over and over again. We're in talks with Bandai Namco on doing a full release of Pac-Man. We're looking at Tekken, we're looking at Galaga, and we're just changing the mechanics so that it's fun and, it really helps people that are neurodivergent in getting something that interests them in fitness.
We talk about the future of wearable AI.
Okay, AI has exploded. Everybody starts talking about wearable AI devices, okay? And we saw the failure of Rabbit. We saw, we're seeing a lot of different wearable AI devices that really are not the future. Honestly, the only way that AI is going to be on a device is through AR, right?
And his experience when developing AI tool for the education system.
I mean, when you think about AI and things, if you develop a tool for the specific cause, don't develop a chatbot, develop a tool that's going to solve a problem for the administration or for the user. And it takes very little to do that. You don't need giant GPUs. You don't need all the data in the world. You just need the data that customer wants to solve.
But before we get into it, I wanted to thank our sponsor Meshy, who made this episode possible. Meshy is a real powerhouse for generating 3D assets with AI. You can start with a simple text or image prompt and get high-quality stylized 3D models in just a minute. There are two features that completely blew my mind. One is the ability to create stylized texture for any mesh, with or without UV. And the other is the ability to edit portions of AI-generated textures like in Midjourney in Painting. The team has been pushing continuous updates, improving significantly the geometry and texture quality, and I strongly encourage you to visit meshy.ai and check out the generous free plan. After that, make sure to use the code XRAI20 to get a 20% discount on your subscription. And now it's time to roll the title and welcome Ernest under the spotlight. Ernest, it is a real pleasure to have you here.
Thank you. I appreciate it. Thanks for having me on the show. It's nice to be spotlighted as one of the future innovators in this great space that we're trying to bring together.
Absolutely. And look, this all happens magically on LinkedIn, a platform where I spend a good amount of time. And I've seen some of the things that you have been sharing, where indeed merging augmented reality with AI as well, and this on the spectacles. on which people have a lot of questions about. So
Yeah.
maybe let's start with that. What has been your experiencing when developing on the spectacles?
All right. So I've been in game development for over 20 years. And in game development, one of the biggest priorities is the IDE, the interactive development environment. For gamers, you have Unreal Engine, you have Unity, and that's where the basis of knowledge has gone for a long time. With spectacles, they are the first platform in augmented reality to have an intuitive IDE that mimics Unity. So now you have creators that have been versed in some of the basic commands and infrastructure of Unity, and they're able to take that knowledge and implement it over. And to make it even easier, instead of doing like C++ and C# coding like Unity uses for a lot of its mechanics, it's been simplified to JavaScript. So what they've done is they've created a way for creators to onboard and build within the Lens community extremely easily. So you can think about not only education, but branding experiences, or people just wanting to do something innovative just to say that they're a creator, right? And being able to push that to the Snap community, get support, and get views and get interactions. Honestly, they're decades ahead of the game from other AR companies because of that interactive development environment.
So far I heard only positive, right? But
Yeah.
are there some negative as well?
They're prototype glasses. There's are a couple of negatives. One is the battery life, of course. It's got a shortened battery life, but I know that internally they're working on those exact things for when they try to go to the production launch. Also, the limited field of view. It does have that great 3D capability and interaction with the spatial context around the world, but it is limited, and I'm sure that the optics team there is working on that as well. Those are about the only negatives that I can see right now. The processors, yes, it uses Snapdragons, and if you put too many 3D elements in there, they will get hot really fast. But, for a prototype, being the first to launch this technology and being able to connect so many different tools, the positives outweigh the negatives immensely.
So I do have a question as well. You mostly mentioned about the hardware, right? In this case, when it was about the negative, I was also curious about the development on it. So in a sense that, for example, even when you have a Quest, you do have these SDKs and packages that allows to deploy this experience. You mentioned about that. It sounds rather robust based on your experience on the spectacles. Is that the case when? Did you manage to do what you wanted to do, keeping into account all the limitation of the hardware that you had?
We were able to do exactly what we wanted to do. I started on this Pac-Man Fit game almost a decade ago. That was our first launch on the Lens Studio. It took us 5 weeks. That's it, 5 weeks to go from prototype, developing assets, setting the stage, setting spatial elements, adding the computer vision elements for the game mechanics, everything. And launching the Lens was literally a minute and a half debacle. It was literally us publishing from within Lens Studio, adding the mechanics, and then them approving it, which I don't know, you probably, launch things on Unity and Unreal Engine. That is not the case on those. You have to go through debugging. You have to make sure everything is implemented. Then you have to make sure you have partnership accounts for deploying on all these things. So what Specs has done just in the social media aspect, I know they thought about games and education and things like that, but just that social media aspect of that instant connection and deployment, they really put the other guys in the dust. And once those 3D graphics and everything start scaling up, when you get out of low poly and you get into high poly, and that's where everything's going to change.
You brought up a very interesting point, and that is actually the distribution, right? That I think on Quest, on Apple, there is like everything has its own, let's say, advantages and disadvantages. I want to talk about that later. But in the first, my one of the questions that I have from the beginning is like, why develop for the spectacles? Nobody has them. Why spend time even on them?
Okay, so we've been developing VR and AR stuff, me personally, for years. Our company just really started going into it the last 6 months. I convinced them we're an ed tech company, And I finally convinced them, hey, this is actually going to be happening. Let's invest a little bit into this. And this is the first implementation. We actually, I started looking at the Rainio X2s, and I did a little bit of Android development on those. And those are honestly the first 3D waveguides that have come out to the public that are massively available, but they're Chinese. A lot of the coding and a lot of the documentation is very insufficient. So I started looking at different, hardwares that were going to be coming out. I looked at Orion. Okay, Meta is terrible to work with, so you definitely don't want to try to develop on Orion. We've actually done some development on the Meta Ray-Bans, and that was a little bit of a nightmare. And their customer service for corporations is not great. And then I started looking at pathways outside. So there's a few others that are not waveguides that are completely occluded that have some pretty good, like 132-inch screen. I can't think of the brand names right now, but have 3D capability. Yeah, that's one. Yeah, X-Reels. Yep, you got it right. So looking at those, I started seeing a lot of the problems with VR, and I've been testing VR for a long time. One of the biggest issues is that ocular occlusion, blocking the eyes. It takes away that spatial context and awareness. And when we started looking at specs, yes, I know they don't have the deployment yet, but they have the manufacturing set, right? And they have the team, they have the social media capabilities. They have all the pieces in line to be the first to put these glasses on the market. And even though they'll be a little expensive in the beginning, they're the only ones that are going to come down in price properly. Right now, they're giving education incentives, right? People with an EDU address, they're letting you get them for $50 a month. Now, that's $600 a year. And, we got in when they were $1,200, still pretty high price point. But when you look at Orion, Meta said that right now it costs like $12,000 to produce a single pair of glasses. That's
honestly, I'm not sure that we can start talking right now about money, because I think that's gonna change so wildly that I think right now it is, as you rightly pointed, it's probably a conversation about who do I want to partner with, who do I want to work with, what kind of glasses I want. Do I see one or another? What are the limitations? So I think those are very good elements to look at. I'm still curious, like you jumped into this and it's like, what did you want to get out of it? Was it about learning how to develop on this, or maybe get some exposure or have some fun? Because those are all very valid reasons, right? What was your objective?
Okay, if we want to get down to the rudimentary reasoning why I got into AR, I started working on some drone vision applications for the fitness industry about 12 years ago, implementing body pose estimation, computer vision. And as I started evolving that project, I realized this could be working for video game controls. This could work for interactive controls for everything, right? So I know you probably remember 9 years ago, HoloLens was making the rounds, Magic Leap was making the rounds, Vuzix, they're still around a little bit, but they were all talking about how they were going to implement this next generation of wearables. And when you put them on, you saw it, right? But then it was giant headsets and everything else. And that I started realizing, okay, I'm going to start shifting to the mobile side. But I've been a coach in Special Olympics for on and off for about 13 years. And, as a coach, I've coached CrossFit, I've coached, powerlifting athletes. And one of the, issues with people that are neurodivergent is doing the same repeating exercise over and over again. When they're training for competitions, they become, kind of disconnected from the exercise. They get bored with it. So a lot of people that are neurodivergent enjoy games. They enjoy immersive experiences. And I wanted to build a bridge between gaming and fitness. And that's where Pac-Man Fit started. And now we have a whole slew of games that are going to be correlated with that. We're in talks with Bandai Namco on doing a full release of Pac-Man. We're looking at Tekken, we're looking at Galaga, and we're just changing the mechanics so that it's fun, it's a good little workout, and it really helps people that are neurodivergent in getting something that interests them in fitness. That's where that started. And then once I saw HoloLens and all those things were never, ever going to be worn in fitness, I started looking at mobile. I started tinkering with Euphoria. That was like 8 years ago. And from there, I kept iterating and trying to evolve this concept until now we are where we have hardware that can be used for it.
It's actually pretty exciting. When I tried it for the first time, I was at NWE in Vienna. I was like, okay, let me try this thing. Okay, a bit bulky, but when you put it on, you really get okay. Now this is kind of working. Like, I mean, yes, of course there are limitations with the field of view, but it's not as bad as I would have imagined, right? And also probably very much depends on the kind of application that you are running, right? Because better application probably run better with a limited field of view than others, and that is up to developers and designer, of course, to put something together that works for that certain device. One question that I have is, so what kind of advice could you give to people that are approaching this? Maybe they manage to get a pair of spectacles and they are jumping into the development. What have you learned that you would like to share with others?
Well, really leverage the Snap ecosystem. All right. So they have Reddit channel with all of the engineers, and they are great with everybody from companies to individual developers. They communicate with everyone and try to get through problems. And they're working on engineering, right? So they're trying to see what these problems are, identify them, and turn them into features and expand. So they're doing an amazing job with that. Definitely get into your JavaScript resources as well. You need to understand JavaScript implementation, because when you're going through and adding functions and you're having different parts of the lens communicate with one another, that's where it's at. It's all in JavaScript. So get good at that, making sure that you understand those internal file structures. Between those two, we have our own suite of functions that we've built that are extremely custom just to us. But I would say 60% of the things that we are implementing are available through all the Snapchat filters. They have code add-ons. They have a great specs tutorial start on kit. So getting buttons and everything implemented, it's really there. And you're seeing a lot of creators that don't have that coding background that are able to start putting out lenses just like that. It's really heartening to see.
That's great. So, and you briefly mentioned also the, let's say, the deployment of the lens, right? So you mentioned that you made a submission, they reviewed the code, if I'm correct. So can you guide us maybe through that, let's say, process?
It's fairly simple. I mean, we communicate with them quite often because we're pushing the limits of the glasses. So we let them look at the code beforehand, but you go through and you compile. You test it on the specs, right? That's what's so great. It's literally just a button to push it to the glasses, and then you're able to test the environment. Once you get through the glitches and you debug, as long as it has a proper compilation and you just hit publish to lens, then you put in the details, the name of it, an icon, a screen, just a little thumbnail for it. And then they tell you it's been submitted. They normally do updates to the lens every 1 week to 3 weeks, and then they send you an email back saying, good to go, it'll be on the next release. It's that simple.
So the other point is the discovery a bit, right? So let's say that you maybe have a lens, have spectacles, and then you would like to see what other people are building, right? There is a Reddit that is, I think, a very good resource where you can show and share as well. But how do you actually find the lenses? Is there maybe like a rating or a like system where you can find maybe the better one? How does that work?
Honestly, you need to go through the platform. So they have a menu of all the deployed lenses, so you could see if it's in gaming or 2-player, education, learning style. They have all of those, and you could just go through and see who the actual developer is. And I know internally for us, we have all of those metrics, so we can look at who's been playing it, all the different specs. I haven't gone into looking at other people's lenses as far as what kind of traction they're getting. I haven't tried that yet because we've been so focused. We're trying to deploy 8 lenses throughout the next 12 months. We're almost finished with 3.
So I think the perfect bridge is, what lenses are you building? So you mentioned Pac-Man. Maybe you can tell us a little bit more about the others.
Absolutely. So Pac-Man is already out. That's that you can play that one on the specs if you have the specs now. We have two that are running in tandem right now. We have Solar IDEX, which is kind of our solar platform for education. It's really every single tool for education you could imagine, with every AI tool that is ethical. We use a lot of open source. We have our own data. We run our own models on our own computation, and we actually pared these models down to be able to run on laptops and mobile. So that's what we're going to be doing, is creating a bridge for all the AI components to be able to run off of a mobile server, which is already connected to your phone. So no more GPUs, no more questions of where data is coming from. That kind of pairs into the whole augmented intelligence. That's where we take a model, whether it's language, machine learning, what have you, and we get the data from the client and we fine tune it for that client, and we put it on a deployment of the smallest amount of compute possible so that they don't have to worry about all of the ecological effects of burning water and energy. They own all their data. It never gets passed through an API so that other people can consume that data. And then let's see, we have a few different APIs connected for weather prediction. We connect to learning management systems. So we have complete education portions with animations, puzzles, everything around the units. Then they take a quiz on it. And then that quiz information gets sent to either Canvas or D2L Brightspace. So that's kind of like how we're modeling education going forward.
Okay. So we made a big jump. So we were let's look at what are these spectacles. We went kind of like deepest into AI learning and large language models. So why don't we take a step back a sec, right? So you were telling me that there is this astronomy. Am I correct?
Or solar industry.
Solar industry. So what people wear the glass, what do they see, what can they do, and how is the content or the input of the user interfacing with this AI that you have built?
Okay, so to break it down, when a user goes in, there are 4 tabs. There's quizzes, there's learning, and then there's data. Now, in the learning section, actually throughout the entire section, except for quizzes, we have a chat, kind of a chat window, right? And in that chat window, we have speech to text. So you speak your questions. If it doesn't get it right, you can edit it, of course. And then we also have a multimodal inference. So you can, in the specs, and this is, a rework from one of Matt, one of the guys at the specs team, where you just open a picture and you've probably seen it for the Pokemon cards. So we adapted that. And now, instead of it going to search Amazon like they originally built it, you can now send a question and an image to a multimodal model. So you can ask it about the information that's being presented. You can ask it for faults on a system. So you can actually go out and look at a solar panel, drag a picture over a broken inverter, and it'll tell you it's a broken inverter and some of the steps to move forward and correct that. So it's a whole engineering and education platform in one. For the actual interactions on the learning, we have complete 3D landscape. So like with Unit 1, it's very simple. We're modeling it towards junior high and high school students. It shows a solar panel, and then the sun comes out and then drags rays down. And your job is to drag the sun so you get the perfect amount of light that goes across it. Then after you get through that aspect of it, you start asking, it'll ask you questions about, how does this convert energy for homes and auto? And now we have a visual after you interact with the animation where it will send power to a car and to a home, right? So that's Unit 1. Unit 2 is learning about the basic aspects of solar panels, the different layers. So during the instruction, you learn about the different layers, and it's a puzzle. Then it jumbles them all up, and you have to put them in order just using standard hand gestures. You're using pinching and dragging, just no controls, very, very simple and intuitive. And then, of course, within it, we also have a anchoring position system for spatial anchors. So it reads the latitude and longitude of that position, and then it sends it to one of our custom AI models that turns the irradiation data, a 15-day prediction that's 99% accurate, and it graphs it out to let you look at how much energy is going to be produced on your specific location to have whatever size system, whether it's a 1 kilowatt panel all the way up to a megawatt.
I just wanted to have a quick break to remind you that if you're enjoying this conversation, you should definitely check out the XR AI Spotlight newsletter. By subscribing, you will get weekly interviews like this one directly in your inbox, an app or product I personally have tested and recommend, and access to a list of over 400 mixed reality apps for Quest that you can easily search and filter. Just check the first link in the show description. And now, let's get back to the show. And so you mentioned that the AI in this case is in the glasses,
No,
because
no.
no,
We
right? It's not on
we have
device.
our own private servers right now on Hugging Face. We are going to be implementing a chain. So we have another software coming out internally from the company where you're able to not only set up your own GPU servers on Hugging Face for your models, download, fine tune, and deploy them, but you can also do it on a laptop and then set your laptop as a server location. And then that server location has an API that the glasses can call. So that's what we've done is we've pared down the specs to be able to call just about any AI API, whether it's OpenAI, which they already do, or Hugging Face for our own, Claude, whatever we want.
So what is this connection between the AR glasses, right, and the AI that, let's say, provide inputs and analyze the images, right?
Yeah.
Like how challenging it is to set up in a sense.
We're the first ones to do it. It was a challenge, and it took us about 2 months. We had to go through and adapt the JavaScript code to be able to run our own APIs. Of course, we're in experimental mode, so we have to work with Snap on how to get out of experimental mode and use our custom JavaScript code for our own functions that we've built into it. It was a little bit of a beast, but luckily, and not just with the specs, we do this with a lot of our applications. We've learned how to take a lot of the different existing code infrastructures that call OpenAI just because it's an API key. Like there's really no AI going on there. It's just calling, sending information to an API key. We've learned to replicate that process to be able to use any API key, whether it's something we generate from Hugging Face, our own Python, with internal GPU servers running on cloud. We've been working on that for a couple of years now.
So that's really interesting. I mean, in a sense, like this lens, right, that you are building in this case about the solar systems, solar powered,
Yeah.
is what do you plan to actually do with it? Like share it with faculties, with schools and
We
colleges?
actually have a couple of different aspects we're running on this one. I've been working on Solar IDEX as a platform for several years, and it's actually, yes, it's meant to be an education tool. It's meant to be a template of everything we can do within education, but we are tailoring it towards appraisers and people that sell solar systems. So if you think about an appraiser going to a site for a house, somebody's interested in getting solar panels put on their roof. Well, one of the aspects that they have to think about is how much energy is it going to produce? Is it logical there? And one of the things that we're implementing with our multimodal AI is not only will you be able to detect faults, like looking at a solar panel, but we're going to have it where these appraisers on a mobile app, not just the specs, but a mobile app, can take a picture of a house from the street view and see if there are trees occluding sunlight. And then it combines that with its location data to make sure that the system is efficient for the sale of that solar panel for the homeowner. So it's meant to be a configurator and an estimator tool, as well as education. And I kind of went a little bit crazy with it. We've had some interest from several universities on building some programs for this. So I thought, you know what? Let's just feature it out. Let's get on this lens and let's go crazy and build everything we can into it. And then we have essentially a buffet for educational institutions to develop courses on, do whatever they want. If they want to develop a course on physics, then we can use this template and then just change the material to physics, build a model for physics, all the above. So that's what it's meant to be, as a template for us to teach, to sell, all the above.
So, because what do you think is going to be the role of this, let's say, maybe in the first place spectacles, but then these AR glasses on a broader terms when it comes to education, because they've been a bit slow in adopting VR, and I don't think it was just their fault. I think it was also like some of these headsets, they are not just made for education in a way, the way you manage the headset, the content that it's in there. So I just think it's totally justified. Now, things are changing. I've seen in education things are moving, at least in the right direction. There are colleges deploying hundreds, in some cases, headset. But what about AR? Right? What do you think?
Honestly, all right. So I don't. I've seen the last few years. Okay, AI has exploded, and then in the past year, everybody starts talking about wearable AI devices. Okay, and we saw the Rabbit, the failure of Rabbit. We saw, we're seeing a lot of different wearable AI devices that really are not the future. Honestly, the only way that AI is going to be on a device is through AR, right? I mean, you're seeing Meta with the Ray-Bans. I've gone through and tested on it. If you augment with sound, it's cute. It works for about 30 to 45 minutes, and then people are bored with it. But when you start bringing in that complete immersion of outside reality, that augmentation, now you're starting to see what the true potential of AI can be. And in an education setting, right now, what you're seeing, and I go into this with people, I've been talking with linguists about this for a long time. What's happening right now in education is there's this push for AI, and it's not really justified. It's what it's doing is it's replacing the learner's doing, right? So there's a difference between learning and doing. And these students, when they do their assignments, they're learning the material by doing the assignments. Now, when they're getting into AI, they're replacing the entire process of accumulating that information, processing it into their own thoughts, and then doing, and they're just replacing it with doing, which means they're not learning at all. It's called cognitive offloading, and it's really starting to push boundaries throughout academic circles because it's showing proof that students in testing that use these tools are doing worse than students that don't use them. Now, with that being said, that's because they are going in with this expectation of using AI just to do things for them. With augmented reality, we're giving them experiences that correlate with the information. So we're giving them learning and doing at the same time with mediums that they're used to, which is like, 3D, gaming, puzzles, these different mediums. So as these glasses start becoming a mainstream, I believe that they are going to be the focal point of how AI wearables are looked at in the future. And then education is going to realize that this might be the only safe way to use AI in the classroom whatsoever.
But so, I mean, if I understand, correct me and correct me if I'm wrong. So what you're also saying is that the way students are assessed in this era of AI needs to change because it's just not representative anymore of what the students of the students learning, right? So we need a different way of assessing it, something that is different, and AR could play a role in it. But of course, I think there might be other ways of doing it as well.
There could be. I mean, I just, from my experience in deploying AI tools in education, it's been nothing but an uphill battle for students. And when you start, and we've got a lot of universities and companies that are extremely excited about the capabilities of having these immersive experiences that are running in parallel with AI processes. And what's really good about our AI processes is, RE, augmented reality plus augmented intelligence. It's about creating these experiences with information that is directly related to that experience. So building a model, and for example, our Solar IDEX model, we're looking at around 2,000 to 3,000 images with, I would say, probably close to 50,000 question answer pairs. And we're able to put all of that seamlessly on a Llama 3.2 11 build vision model, MLLM, and it has zero hallucination. That's the difference between large language models and small language models, is when you fine tune that information down, it doesn't hallucinate because it's not trying to run a probabilistic algorithm of multiple sources of data. It knows that one source of truth and it puts it out. And that's where we're seeing the advancement in education, is going for this focused language models, as we like to call it. So those are fine-tuned small language models.
So I think that a lot of people listening might also be at this point curious, like what are some of these AI models that you deployed and how, like to do what specifically? Can you give us some examples?
It's a Llama 3.2 11-bill vision model. We'll probably upgrade that to DeepSeek. The Janus Pro, that just came out today, and it's blowing everybody out of the water. And they actually have it working on I think a 1-bill and a 7-bill version, which is insane. We have those for language model architecture. We have a few different implementations of Llama 3.31 bill. We are working on a chain of thought using DeepSeek R1, that 7-bill version. So they have several pared down versions. The largest one that's running API is like 678 billion parameters, but they distilled it down to 1-bill, 7-bill, and 32-bill versions of it that still beat OpenAI or the O1. That's definitely a really good one.
But for what specific application, if I may ask?
So Solar IDEX, we have some other applications internally. I can't talk about too much on those because they're proprietary, but I can give you a structure of one of them. We have a Llama 3.2, I think it's a 7-bill version on top of a graph network. This is our skills. We have a skills database tool that we use for universities to take in syllabi and course information and appropriate skills to it. And we completely eliminated hallucination, reduced model outputs by putting a graph network underneath a language model network. So we're actually creating deterministic language pathways for our specific use cases. And that thing works amazing. What are some other ones?
In this case, the use was to analyze the skills, like I mean, what data are fed.
Okay, so it's used for specifically the registrar's office and the accreditation office within a university. So if you have syllabi from an outcoming university, or you have students transferring in, they have courses that are associated, right? So maybe they had an introduction to computer science, something simple like that. Now, they're transferring into the university, and they need to create a correlation between that course and a course that is within their home institution. So once they create that bridge, they also have a definitive set of skills that they've learned, primary, secondary, and tertiary skills, as well as an aptitude grading that goes along with it. So we use those syllabi and course descriptions and things, and we run it against the architecture of our graph network with all the descriptions of everything we have of each skill. And it searches the entire, we're at like 450,000 skills now, searches them and then allocates it. And then based off of their grade, gives them an aptitude level of what skills they have. So if they get a D in something, then they'll show that those skills that they have for that course need improvement. And then it'll show this incoming university, okay, so this student has these skills. They need to be able to take these to upskill to get to where they need to go for a degree pathway.
And so it is, in a way, a support for the teacher, for the education system, more kind of like to run the operation within education, so to say.
Most of our tools are for the administrations within academia. So we work heavily with them and how they help us design for education.
And this is another interesting point, because usually when we think about AI in education, we immediately think about the students who write the essay, go to ChatGPT and add something. I mean, like, let's broaden a little bit our horizon. Like, and I think like education, this could be something that takes also for the social security system or whatever, right? I mean, at that point, different data, but the purpose, in a way, it's comparable.
And that goes back to the point of developing tools for the use case. This entire tool system that we have runs on a 4 vCPU server. All right. The entire tool for an entire school and everybody runs on a very small server. The data load is very minimal. It's tiny, but it's extremely targeted. So, I mean, when you think about AI and things, if you develop a tool for the specific cause, don't develop a chatbot, develop a tool that's going to solve a problem for the, administration or for the user. And it takes very little to do that. You don't need giant GPUs. You don't need all the data in the world. You just need the data that customer wants to solve.
And this is, I think, that in a time where we're just trying to make things bigger and bigger and bigger, and then we don't even know how to manage and deploy in a way. I think this is like probably the best advice. I mean, you have given many, but in general, best advice, like develop something for a tool. There are so many ways in which this can be useful. And I think there could be entire businesses built just around solving one of these problems, right?
Exactly.
So,
yes. And the world got a wake-up call today. When DeepSeek took over as the number one model in the world, even on download, or not just downloading open source, but the mobile app, they spent $5.5 million on training a reasoning model, which is just a chain of thought, right? It's just chain of thought for a specific case. And they focused it on science. They focused it on science and the specific things that were meant. So now they have a distilled version. The 32-bill version can run on a laptop and outperforms O1. So what we had today was a realization that these giant, bigger is better, which all data scientists have been saying this since ChatGPT came out. It's like, this is the wrong method. You don't need all that data. You don't need all the computation. Why are you continuing to go down this road? Today was that wake-up call of, smaller models are going to win. Direct use case is going to win. And we don't need all of this $500 billion in infrastructure.
And this kind of, I feel like this somehow in some weird way connects where we started, in a sense that I think also when we look at augmented reality, people are thinking of building something that feels like a fully fledged game or experience. And I somehow believe that when we think about augmented reality, it's the feeling of the apps that are going to succeed. It's going to feel more like a widget that solve a specific thing on top of reality, other than, oh, we are having this full immersive experience with controllers and shit. It's like, I don't think so.
I think 5 to 10 minutes. Those are the interactions that are going to sell like crazy. 5 to 10 minutes and something that's interactive. It either triggers, some creativity and curiosity, or you get into fitness. Those two things, like if you grab their attention for 10 to 15 minutes and then they're satisfied or they're smoked, right? In the military, we say you're smoked.
I think that another good word is it's utility. So the moment that you can get immediate value even from a 10, 20 seconds interaction, right, in with something as a digital content that appear there, I think it's going to be enough. And of course, there's going to be someone that maybe want to play a game or maybe you want to have a call with someone, right? But I think that aspect where it's something so minimal that is going to help you in doing one thing that you want to do at that specific moment in that specific place, that's, I think, something that we should look towards instead of the bigger blockbuster experience when in augmented reality. VR is a different story, and because you need to be immersed, there is a lot to do. But when you're in augmented reality, there is reality first.
I agree with you, and I would expand. You said the perfect thing, the place. Now, I think one of the big separators in virtual reality and augmented reality, especially when AR starts pairing up, is you're going to see a lot of community experiences. Think about, and this is something I'm trying to organize and get together, but think about in the summertime, you go to a park and the football field is just absolutely immersed, and maybe a brand or a local company decides, hey, I'm going to put out this gaming experience like Batman, right? And I'm going to give out a prize to everybody that shows up and has the best time. And then you just see people sharing the glasses and doing these interactive experiences in a special place that connects them with the community, with the brand owners. It gets them in that physical space together. And that's what's lacking in virtual reality and a lot of these things, is that spatial ability to connect people. I know people are, sucked into their phones, but whenever this technology bridges over and they can really share these things together, I think it's going to change the whole paradigm.
Ernst, I wanted to thank you. I think we went a long way. We went from AR to AI to
Yeah.
AR back. So
Yeah.
absolutely, I really appreciate this, and I'm really sure that a lot of people here have learned a lot. Do you have anything else? Last remark.
No, just follow Sajax. You'll see what we're doing. Looking forward to what we're going to be putting out some stuff with the University of Idaho. We're also working with the University of Maryland, Baltimore County on some really cool things. We're going to be at ASU GSV this year, so we'll have a lot of pair of glasses there. So if you want to see us, we're going to be demonstrating games, educational experiences, talking about some of our other educational tools for administrations. But yeah, thank you for having me on. It's been a great conversation. You definitely know the pathway going forward.
Awesome. And of course, you'll find the link down in the description. Thank you very much, and it was a pleasure.
Absolutely.
Thank you very much for listening in. If you like the show, remember to leave a rating on Spotify, Apple Podcasts, or a thumbs up on YouTube. It really helps me keep doing this and shine the spotlights on the greatest founders and makers, pushing the boundaries of XR and AI. Also, make sure to check out the show page xraispotlight.com, where you can find more conversation like this one. Till next time.